Hello, my name is Arianna De Abreu, and today I want to explain a little bit more about formation of crystals, specifically monoammonium phosphate. First, we need to know how is a crystal formed. Crystals form in subterranean cavities as atoms join in predictable three-dimensional patterns. Each crystal begins tiny and gradually expands, and additional atoms are added, many driving water with a high concentration of dissolved minerals. This isn't a must. Crystals can form from molten rock or even vapors. But how is monoammonium phosphate formed? In a common method, a 1:1 ratio of ammonia and phosphoric acid is reacted, and the resulting slurry of MAP is solidified in a granulator. MAP is the common name of monophosphate. The second method introduced the two starting materials in a pipe cross reactor, where the reaction generates heat to evaporate water and solidify. So now I want to explain a little bit more about diffusion and how it's applied in monoammonium phosphate. So diffusion is a consequence of the constant thermal motion of atoms, molecules, and particles that results in material moving from areas of high to low concentration. So in 2019, diffusion analysis was developed to commercialize a specific system for recovering the high purity phosphoric acid and manufacturing monoammonium phosphate. So this is one example of how we can see diffusion in um, this type of crystal. Here we have the 3D model of monoammonium phosphate. So this will be the one that we're gonna, if we want to do the 3D printing, we use this type of model. Now I wanted to explain a little bit more how I did the 3D model and also a representation of the molecules. So I used Fission 360. We have here the representation of NH4 plus H2PO4 molecules union. So for the first model, I identified the molecular structure of monoammonium phosphate and how it would look graphically. Then model it using four spheres 120 degrees apart connected to a center sphere using cylinders. Using an appearance tool, I painted the center sphere blue representing nitrogen and the outer spheres white representing hydrogen. This completed the NH4 molecule. Then for H2PO4 molecule was modeled by copying the NH4, adding two extra spheres and repainting it. The center sphere represents phosphorus, the surrounding spheres are oxygen, and the two outermost spheres are hydrogen. Now for the second model, that is the actual representation of the crystal, we look some real life models of monoammonium phosphate so I can get inspiration and model a center rectangle with chamfers on all edges to give it a more crystal look. Since the real life monoammonium phosphate isn't very symmetrical, I added a few shards to the sides of the main structure to produce a nice crystal look, and I painted it blue so and changing a little the transparency so it will have like a nice view when you print it out. Now I want to talk about a little bit a few things that you don't know about monoammonium phosphate. As I mentioned before, this molecule is commonly known as MAP. Is an important granular fertilizer. It's water soluble, dissolves rapidly in an equally moist soil. No special precautions are needed with the use of monoammonium phosphate, and it's a good storage and handling properties. This things is when we have this component as not in crystal. But I think it's a really good important things that we need to know before having it in another path.